Okay, hello students. So today we are going to solve. Today we are going to solve the previous year question of matrices and determinants, right? So okay, so the first question is let A, B, C be a three matrix. The three matrix given are A, B, C matrix such that A is a symmetric matrix. It is given that A is a symmetric matrix. Okay, and B and C are skew symmetric matrix, right? So we know the properties of symmetric and skew symmetric matrix. It is given that A is a symmetric matrix and B and C are skew symmetric matrix, and we have been given two statements, right? There are two statement given in the question. First statement is consider the statement S1 and S2. The first statement is A to the power 13 and B to the power 26 minus B to the power 26 and A to the power 13 is symmetric, right? And the second statement given is A to the power 26 multiplied by C to the power 13 minus C to the power 13 and A to the power 26 is symmetric matrix, right? And now there are four options. The four options are given as the statement 2 is true, the statement 1 is true, both statement 1 and 2 are false, or both the statement S1 and S2, that is the statement 1 and 2 are true, right? So this question was asked in 2023, right? So this question was asked in the year 2023, right? Let's see what we can do. The first data given is that A is a symmetric matrix. Since A is a symmetric matrix, so we can write it as A transpose is nothing but A, right? When we do the transpose of A, it will be equal to A only, right? Because it was given that A is a symmetric matrix. Again, also B and C are given a skew symmetric matrix, so the transpose of B will be equal to minus B, and the transpose of C will be equal to minus C, right? So these are the three things we can write from the questions. Now the first statement, right? A13 B26 minus B26. Let's consider this statement as equal to M, right? Let M is equal to, we can write M is equal to A13 B26 minus B26 and A13, right? Let's write it as equal to M, right? So I have written this as equal to M. Now we write what we can do. Let's transpose the M. Let's transpose the M. So we can write M transpose is equal to A13 B26 minus B26 and A13, and we can write it as a transpose, right? We can write it as the transpose of A13 B26 minus B26 and A13, okay? Now what we can see, we can write this as A13 and we can simplify that A13 and B26 and transpose minus B26 and A13 transpose, right? We can write it as this also, right? Now further simplification will give B transpose and to the power 26 into A transpose to the power 13 minus A transpose to the power 13 and multiply by B transpose, right? B transpose, I'm using the properties of a transpose only, right? B transpose and 26, right? So this we can write B transpose 26, A transpose 13 minus A transpose 13 and B transpose and 26, right? So now what we can see, we can write this as B transpose 26. B transpose 26 is what? B transpose is equal to minus B and minus B to the even power. Even power is given as 26. So what we can write, even power, either we do the even power or this is minus B to the power 26 or B to the power 26 will give the same result. As we know that if we do the minus 2 square or we will do the 2 square, both will give the same result. So we can write it as B transpose 26 as nothing but B26, right? So this I can write as B26. Okay, and A transpose 13. A transpose is equal to what? A transpose is equal to A only. So this I can write as A to the power 13. Okay. And next what we can write, A transpose 13 is nothing but A to the power 13, because A transpose is, from the question it is given that A transpose is equal to A only, right? And finally we can write B transpose as B transpose is minus B, but minus to the power even power is equal to the B to the power even power, right? So we can write it as B transpose 26, right? Now compare this, what we got the result, compare this with M, right? M is what we have taken as A13 B26 minus B26 in A13, and it is just, this is the minus sign in between. This is minus sign in between, right? And this is B26 A13 minus A13 and B26. So this is just equal to minus of M. The result what we got after transpose is just negative of M. And if the transpose is negative of, right, if we do the transpose and it become negative, then we call it as skew symmetric matrix, right? Then we call it as skew symmetric matrix. So the first statement is not correct. Statement 1 is not correct because it is given that this is a symmetric matrix. This is actually skew symmetric, right? So the first statement is not correct. So I'm crossing here, right? This one is not correct. Now let's check for the second statement. I'm erasing this one so that I can check, I can verify the second statement, right? So I'm erasing this one. Now verify the second statement. As we have taken the first statement as what? M I have taken. Now let's consider the second statement as N, right? Let's consider the second statement as N, and if we consider the second statement as I can write A26 C13 minus C13 and A26, right? The procedure we will be following is the same, right? How we have checked the first statement, the same procedure we will be following. And now I can write N transpose. N transpose is nothing but the transpose of this whole, right? C13 minus C13 and A26 transpose, right? So this is the transpose of this. Okay. Now what we can do, I can bifurcate it, right? I can bifurcate it as A26 and C13 transpose minus C13 and A26 transpose, right? I can bifurcate this, right? Now again I can bifurcate, right? Again I can simplify it as, I'm simplifying here, is equal to nothing but C transpose 13 and A transpose, this will become A transpose 26 minus A transpose 26 and C transpose and 13, right? This I can write C transpose 13. Okay, now C transpose is what? C transpose is negative of C, right? C transpose is equal to minus of C, and minus of C to the odd power. It is different from what? C to the power. In case of even power, I can write it as C to the power. If it is even power like 14, so either I can write it as C to the power 14 or I can write it as minus C to the power 14. It is equivalent, right? But in case of odd power, this I have to write it as minus C to the power 13, right? This I have to write minus C to the power 13, and A transpose is what? A transpose is from the question A only, so this I can write A to the power 26, right? This I can write it as A to the power 26 minus A transpose is again A to the power 26, and C transpose is what? Minus of C, minus C 13, right? So this negative will multiply here and this will become positive, right? This sign will become positive, and I can write here C to the power 13, right? Now I can interchange it, the positive sign I can write on this side, and the left hand side I can write. Okay, so I can write here, this is equal to A26 C13 minus C13 and A26, right? A26 C13 and minus C13 and A26, right? This I am writing here. Now compare this one. Compare this one with the statement 2. right? If I will compare this with the statement 2 or what we have taken n, right? So it will be better if I compare it with this statement, right? The statement n, right? Now compare this what we received here on the final solution is it is equivalent to, it is just similar to what we have taken n, right? So the transpose of n gives the result as n only, right? And we know that if the transpose of some matrix gives the result as same thing, so this we call as symmetric matrix. So statement 2 is correct. So in that case, I can say that statement 2 is correct statement. So from the option, I can see that only statement 2 is correct. Okay. So option A is correct. Option A is correct option. The rest are wrong. Right? For those who want to take the screenshot, they can take the screenshot. Okay, so now we will move to next question and let's see what the next question is. It is also from the matrix and determinants, right? And the question is that let A be a symmetric matrix such that a determinant of A is equal to 2, such that the determinant of A is equal to 2, and this matrix is given a 2 cross 2 matrix, and 2, 1, 3 and 3 upon 2 multiplied by that matrix, right? A matrix is equal to 1, 2, alpha and beta, right? So it is given that the sum matrix 2, 1, 3 and 3 upon 2 when multiplied by the matrix A, which is symmetric matrix, is equal to 1, 2, alpha and beta, right? Further it says, the question says, if the sum of the diagonal element of A, right? If we add the diagonal element of A, so this is S. What is this? This is S. Then we have to find, finally we have to find beta S upon alpha square, right? Okay. So how to proceed in this question? Let's start. First we have to assume a symmetric matrix, and we know the format of the symmetric matrix is what? A format of, let's suppose I'm writing here the solution. I'm considering a symmetric matrix, and we know the symmetric matrix is always of the form A, B, B and C, right? Why I have written like this? Because when we change the row to the column, right, it will again be equivalent to the previous matrix. So if I will interchange the rows with the column, it again will look like the previous matrix only, right? So this is a symmetric matrix format. Now the question says when we multiply this 2, 1, 3 and 3 upon 2 with A, with this matrix, we will get 1, 2 alpha and beta. Okay, so following the question instruction, what I will do, I will multiply this one 2, 1, 3 and 3 upon 2. This I will multiply with the matrix what I have considered A, B, B and C, right? Okay, and the answer I will be receiving is 1, 2 alpha and beta, right? So this is given in the question, right? I have considered only this one, and this is given in the question when we will multiply this, right? When we will multiply this 2, 1, 3 and 3 upon 2 with this matrix, the end I will receiving is, the answer I will receiving is 1, 2 alpha and beta. Now multiply this, right? And we know the matrix multiplication, which is very easy, right? We have to multiply the first row with the first column, first row with the second column, then second row with the first column, and second row with the second column. So let's proceed. So when we will multiply the first row with the first column, I will be getting 2A plus B. 2A plus B, and this will be equal to 1. When I will multiply the first row with the second column, so I will get 2B plus C, and this is equivalent to 2, right? When I will multiply the second row with the first column, I will get 3A plus 3 upon 2B, and this is equivalent to what? Alpha. Okay, and second row with the second column, 3 to the 3B plus 3 upon 2C, and this is equivalent to what? Beta, right? So these are the 4 equations what we can get from the matrix multiplication. This is 2A plus B is equal to 1, 2B plus C is equal to 2, 3A plus 3 upon 2B is equal to alpha, and 3B plus 3C upon 2 is equal to beta, right? So this I have got. Now one more thing is given, that determinant of A is equal to 2, right? Determinant of A is equal to 2. It is given in the question, right? It is given in the question. So what is the determinant? Determinant is nothing but we will cross multiply AC minus B square. AC minus B square is equal to what? AC minus B square is equivalent to what? AC minus B square is equal to 2. Now from this question, from these four equation, let's find the value of A. What we can write from A? From this equation, I can write A is equal to 1 minus B upon 2, right? A, I can write it as 1 minus B upon 2, right? So I'm writing instead of A 1 minus B upon 2. And this A value I got from here, right? And C value from, if we will solve this equation, right? 2B plus C is equal to 2, I will be getting 2 minus 2B. So C is equal to what? 2 minus 2B, right? C is equal to what? 2 minus 2B, and this minus B square will remain here, and this is equal to 2, right? Now the benefit which I am getting from this is, from this transformation is, right, all the terms are in B, right? All the terms are in B only. Now I have to multiply these two, right? So first I will multiply these two. Half into 2, half into 2 is nothing but 1, and then half into 2B is what? Minus B. Again minus B upon 2 into, so again this will I am getting minus B only, and minus B upon 2 is what? Plus B ka square, and this is equal to minus B square, and this is equal to 2, right? Now if I will solve, minus B square and plus B square will get cancelled. 1 minus 2B is equal to what I am getting is 2, right? 1 minus 2B I am getting is 2 only. So in that case B is equal to what? Minus 2B is equal to 2 minus 1, this is equal to 1 only, right? And B is equal to minus 1 upon 2, right? So one value I got is B is equal to minus half. One value which I got is B is equal to minus half. Okay. Now I have to solve for the value of A and the value of C. So simply I have to put the value of B and B in this equation and this equation to get the value of A and C. I have to put the value of B here and B here so that I can get the value of A and C, right? So let's see how we can find B. If I will put in this equation 2A, I hope this is visible, right? Okay, yes. 2A minus half is equal to 1. 2A minus half is equal to 1. So this I will get as 2A is equal to 1 plus 1 upon 2, and 2A is equal to what? 3 upon 2, and A is equal to what I got is 3 upon 4, right? I also got the value of A is equal to 3 upon 4, right? Now I have to find the value of C, and C, what I have to do, I have to make it, I'm making it this one smaller, right? Okay. So now I have to find the value of C, right? And how we can find the value of C? Just put the value of B in this equation. So if I'll put in this equation 2B plus C is equal to 2, right? And I have to put the value of what? B. So 2 multiplied by minus half plus C is equal to 2, right? So this 2 will get cancelled and C is equal to 3. What we got is C is equal to 3. Now I have three values. A is equal to what? A is equal to 3 upon 4, B is equal to minus half, and C is equal to 3. These are the three value I got. Now I have to find the value of what? I have to find the value of alpha and beta. I have to find the value of alpha and beta, right? Alpha and beta, how we can find? From these two equations. From these two equations, I have to find the value of alpha and beta, right? So let's see what is the value of alpha and beta. I am erasing this one so that, or else I am finding it, right? Let's see how we can find alpha. 3a plus 3 upon 2b is equal to alpha, right? I know the value of A, so this is 3 into 3 upon 4 plus 3 upon 2. Beta I know the value minus 1 upon 2. B I know the value, and this is equal to alpha, right? So solving this, this is equal to 9 upon 4 and this is equal to minus 3 upon 4. So this will be equal to 6 upon 4 and the alpha of value will be get is 3 upon 2, right? Alpha value is equal to what? 3 upon 2. Now we have to find one more value that is equal to beta, and beta is what? Beta is equal to 3b plus 3 upon 2c, and solving this 3 into minus 1 upon 2, 3 into minus 1 upon 2, right? So 3 into minus 1 upon 2 plus 3 into 2, and the value of c is what? 3, right? So this I will get it as minus 3 upon 2 and plus 9 upon 2. So this is equivalent to what? 9 upon 2 and 3, 6 upon 2, and beta we will get is equal to 3, right? The value of beta is equal to 3, right? And S is the sum of the diagonal element. So sum of the diagonal element is what? The matrix what we assume was A and C. So this is the sum of the diagonal element. So simply we have to add the value of A and C. A is written here, and C is written here. 3 plus 3 by 4, right? S is equal to A plus C. This is the diagonal element sum, and this is equal to A plus C. This is equal to 3 plus 3 upon 4. This is nothing but 15 upon 4, right? So now every value we got every single value. I'm marking here so that you can see. A is equal to A upon 3, 3 upon 4, B is equal to minus half, C is equal to 3, alpha is equal to 3 upon 2, beta is equal to 3, and S is equal to what? 15 upon 4. So these are the 5 values I got. 6 values, sorry. Okay, now we have to find beta into S upon alpha square. So the value of beta is what? I have to find the beta S upon alpha square. So beta is the what? Beta is equal to 3, right? Beta is equal to 3. S is equal to what? 15 upon 4. And alpha square is what? 3 upon 2 square, that is equal to 9 upon 4, right? So when we will solve it, 9 upon 4, this will go up, and this will as 3 upon 15 upon 4 into 4 upon 9. This 4 and this 4 will get cancelled, right? This 4 and this 4 will get cancelled, and this is equal to 3 1 the 3, 3 3 the 9, 3 5 the 15. So the final answer we will be getting is equal to 5. The final answer we will be getting is 5, right? So the answer of this question is 5. The answer of this question is 5, right? Okay, now we will move to the third question, and let's see what the third question is. Okay, so the third question is, which of the following cannot be obtained from the matrix? And the matrix given is, this is the matrix given: 1, minus 1, 2, 1 and minus 1 by a single elementary row operation. So we have to perform a single row operation, right? We have to perform a single row operation, and the question says that which of the following matrix, that is option A, B, C, D, right? A, B, C, D, which of the following option cannot be, we cannot get these options, right? By single, only we have to perform one row transformation, and which of the following is not possible, right? So let's see what we can do. We can check each and every option. The first option, first time writing the matrix. The matrix given in the question is 1, 2, 1 and minus 1. Let's see by single elementary transformation, single row transformation, we can get this matrix or not. A matrix we can get or not. So the matrix A is 0, 1, minus 1 and minus 1, right? So if I write the row 1 as of this matrix, if we write row 1 as row 1 plus row 2, let's see what we will get. if we write the row 1 as row 1 plus row 2, so this minus 1 and 1 we will be getting as 0, right? And 2 minus 1 is what? 2 minus 1 is 1, right? And 1 and minus 1. So what I got is 0, 1, 1 and minus 1. This is similar to the option A. So by single transformation, and the transformation was what? Row 1 plus row 2. Row 1 is equal to row 1 plus row 2. So we got this option A, right? Now check for the option B. Minus 1, 2, 1 and minus 1. This is given in the question. And what we have to get? We have to get 1 minus 1 and 2, right? So I can write as if I interchange row 1 and row 2. If I interchange row 1 and row 2, let's see what we can get. Row 1 and row 2 interchange will give me 1 will get here, 1 will shift here, 1 minus 1 will shift here, minus 1 will shift here, and 2 will shift here, right? This is similar to the option B. This is similar to the option B, right? And now see, the option C is a larger number 7, right? And option D contains the smaller number 3. So let's check for the first D option, right? If I check for the option D, so the option D, first I will write the question only, 1 minus 1, and right? And let's see if we will get the option D. If we will get the option D, so the option C will be the correct option, that this cannot be, this is not possible by single elementary row transformation, right? So let's check for the D first. And let's see how we can get the D option. So if I write row 1 is equal to row 2 plus 2R1, row 2 plus twice of R1. I am writing the row 1 as row 2 plus twice of R1. So let's see what we'll get. I have to write row 2. Row 2 is 1 and plus of twice R1. Plus twice R1 is 1 minus minus 2. 1 minus 2, that is equal to minus 1. And again row minus 1 and plus 2. Minus 1 and plus 2 is minus 1 and plus 4. This is equal to 2. So twice of R1 will be 4. Minus 1 and